Imagine a city in space, not just a space station but a sprawling metropolis. This city could house millions of people. It would orbit the Earth or perhaps another planet. People would live, work and raise families in this celestial city. This dream seems like science fiction, but it could become reality. Building megastructures in space is a fascinating idea that we are getting closer to achieving. When we talk about megastructures, two concepts come to mind: Dyson spheres and O'Neill cylinders. These are not just figments of science fiction, but are grounded in theoretical science and engineering. They represent humanity's ambition to harness and utilize space in ways that are currently beyond our reach but not beyond our imagination. A Dyson sphere is a hypothetical structure that completely encompasses a star. Proposed by the physicist Freeman Dyson, this megastructure would capture a large portion of the star's energy output, providing an almost limitless supply of power. Imagine a vast array of solar panels or a shell-like structure surrounding a star, absorbing its energy and transmitting it back to a civilization. It would capture a large portion of the star's energy. This energy could then be used to power everything from cities to spacecraft, making interstellar travel and colonization feasible. The concept of a Dyson sphere pushes the boundaries of our current technological capabilities, but it also inspires us to think about what might be possible in the future. This energy could power a civilization for ages. Imagine cities that never run out of power, industries that operate without polluting the environment, and a society that thrives on clean, renewable energy. The potential benefits of such a structure are immense, and it challenges us to think about sustainable ways to meet our energy needs. An O'Neill cylinder, on the other hand, is a rotating habitat. Proposed by physicist Gerard K. O'Neill, this cylindrical space colony would rotate to create artificial gravity through centrifugal force. The interior of the cylinder would be designed to support human life, with areas for agriculture, living spaces, and even recreational facilities. It would use centrifugal force to simulate gravity. This means that people living inside the cylinder would experience a force similar to Earth's gravity, making long-term habitation in space more comfortable and sustainable. The design of an O'Neill cylinder includes large windows to let in sunlight, creating a natural and pleasant living environment. This spinning cylinder could provide living space for a large population. Imagine entire communities living in space with schools, parks, and businesses, all operating within the cylinder. The idea of space habitats like the O'Neill cylinder opens up new possibilities for human expansion beyond Earth, offering a solution to overpopulation and resource scarcity. The possibilities are truly awe-inspiring. As we continue to explore and understand the universe, concepts like Dyson spheres and O'Neill cylinders remind us of the incredible potential that lies ahead. They challenge us to think big, to innovate, and to push the boundaries of what we believe is possible. The future of space exploration and habitation is limited only by our imagination and our willingness to turn these dreams into reality. Constructing a megastructure like a Dyson sphere presents many challenges. One of the biggest hurdles is the sheer amount of material needed. We would need to harvest resources from asteroids, moons, and even planets. This would require advanced mining and transportation technologies. We are still developing these technologies, however, the potential rewards are enormous. Imagine harnessing the power of an entire star. Speaking of energy, solar power satellites could play a crucial role in building and powering space megastructures. These satellites would collect solar energy in space, then they would beam the energy back to Earth or other locations. This would provide a clean and nearly limitless energy source. With enough solar power satellites, we could power entire cities, industries, and even spacecraft. Section 5. Building blocks. Lessons from the International Space Station. The International Space Station, or ISS, is one of humanity's most remarkable achievements. Orbiting Earth at an average altitude of 400 kilometers, it serves as a living laboratory where scientific research and technological advancements are made every day. We are not starting from scratch when it comes to space construction. The ISS has been continuously inhabited since the year 2000, providing us with over 2 decades of experience in living and working in space. This experience is invaluable as we look to the future of space exploration and construction. The International Space Station, or ISS, is a testament to human ingenuity and collaboration. It was built through the combined efforts of space agencies from the United States, Russia, Europe, Japan, and Canada. This international partnership has shown us what can be achieved when nations work together towards a common goal. Assembling the ISS in orbit taught us valuable lessons. The process required meticulous planning, precision, and coordination. Each module was launched separately and assembled in space, a feat that had never been attempted before on such a scale. This has provided us with a blueprint for future space construction projects. We learned about working in the harsh conditions of space. Space is an unforgiving environment with extreme temperatures, radiation, and microgravity. The ISS has been a testing ground for developing technologies and techniques to overcome these challenges, ensuring the safety and efficiency of future missions. We now know more about assembling large structures in a microgravity environment. The ISS has shown us that it is possible to build and maintain complex structures in space, paving the way for future endeavors, such as lunar bases and Mars habitats. The ISS is a stepping stone. It represents the first step in humanity's journey to becoming a multi-planetary species. The knowledge and experience gained from the ISS will be crucial as we venture further into the cosmos. It paves the way for even more ambitious space construction projects in the future. Concepts such as space habitats, orbital shipyards, and interplanetary spacecraft are no longer just science fiction. They are becoming a reality, thanks to the lessons learned from the International Space Station. One crucial factor making space megastructures more attainable is the decreasing cost of space travel. Reusable rockets developed by companies like SpaceX are making significant strides in reducing launch costs. As space travel becomes more affordable, accessing resources and transporting materials to construction sites in space will become easier and more efficient. This steady progress in lowering the financial barriers to space exploration is vital for realizing our megastructure ambitions. Asteroids, often seen as celestial wanderers, are more than just floating rocks in the vast expanse of space. These ancient remnants from the early solar system hold secrets and resources that could revolutionize our approach to space exploration and engineering. They hold immense potential for space engineering, offering a wealth of materials that are rare or difficult to obtain on Earth. Imagine a future where space stations and spacecraft are built using materials sourced directly from these celestial bodies. These rocky bodies contain vast amounts of valuable resources such as water, metals, and platinum group metals. The surface of an asteroid can be a veritable gold mine, with veins of metal running through it, waiting to be harvested. Water, one of the most crucial resources for sustaining life, can be found in abundance on certain asteroids. This water can be broken down into hydrogen and oxygen, providing not only drinking water but also essential components for fuel and breathable air. Imagine spacecraft refueling in space, reducing the need to carry large amounts of fuel from Earth. Astronauts could have a reliable supply of oxygen, making long-term missions more feasible and less dependent on Earth-based resources. Metals like iron and nickel, which are abundant on many asteroids, can be used for construction. These metals can be extracted and processed in space, allowing for the creation of robust structures without the need to launch heavy materials from Earth. Platinum group metals, though rare on Earth, are found in significant quantities on some asteroids. These metals are essential for electronics and advanced technologies, making them highly valuable for both space and terrestrial applications. Harnessing these asteroid resources will be crucial for sustainable space exploration. By tapping into these extraterrestrial materials, we can reduce the cost and increase the efficiency of space missions, paving the way for a new era of discovery and innovation. The construction of megastructures such as space habitats and large-scale research facilities will become more feasible. These structures could support human life far from Earth, opening up new possibilities for colonization and scientific research. As we look to the future, the potential of asteroid mining and resource utilization becomes ever more apparent. The dream of a self-sustaining human presence in space is within our grasp, and asteroids may hold the key to unlocking this incredible potential. With advancements in technology and a growing interest in space exploration, the day when we can fully harness the resources of asteroids is fast approaching. This treasure trove of materials will not only support our ventures into the cosmos, but also transform our understanding of what is possible in space engineering. The prospect of building megastructures raises profound questions about our future in space. Could we someday reshape our solar system to better suit our needs? Imagine terraforming Mars, building orbital rings around Earth, or constructing vast solar energy collectors. These ideas may seem like science fiction today, but they could become reality with continued technological advancements and a spirit of bold exploration. Building megastructures in space is a daunting but inspiring goal. It will require significant technological advances, international cooperation, and a long-term vision. However, the potential payoff is enormous. Space megastructures could provide us with new homes, vast resources, and a deeper understanding of our place in the cosmos. As we continue to explore and push the boundaries of human ingenuity, the dream of building cities among the stars might be closer than we think.